Today's activity is based on acceleration as opposed to the last activity you did, which was constant velocity. You take a look at the picture here, it looks real similar to the picture you would have saw for the last lab. We have a dynamics cart. We have a motion sensor that's connected to, right here, it's an older version of what you guys are using. We call it the AirLink that connects via Bluetooth to your iPhone. We have a track, the track in which you'll run your cart on. Now, notice what's different about this. Underneath this cart, underneath this track, are a couple books. We want there to be a slope this time because we want to have an acceleration. We don't want a constant velocity. When I was talking to you about some of the mistakes you made on your constant velocity lab, I said, look, we wanted to have a flat surface, a horizontal level surface. We don't want to have a horizontal level surface this time. We want to have something that's sloped. But one thing that I'll point out to you is that you don't want to have too much of a slope. If you do, if you put 16 books underneath this, it's going to be really, really slanted, and it's going to go down this track very, very quickly. The data, you're not going to get very much data at all because it's going to be off the track before you know it. You want to have enough of a slope to give you a clear acceleration for this thing to actually roll down the track, but not too much of a slope to cause it to go down too quickly. We don't want to have an acceleration anywhere close to 9.81 meters per second squared. Okay, we want it to be something quite a bit smaller than that. Does that make sense? I don't think I even really have to tell you a procedure right now, but I will address it a little bit. Okay, basically, what you're going to do is put your cart up here near the motion sensor. Make sure the motion sensor is aimed at the cart, just like it was in your constant velocity lab. Okay, press start on your iPhone once you've got it connected via Bluetooth, and then let the cart go. Make sure you stop the timer on the iPhone, and then you're going to email the data to yourself, just like you did, okay, just like you did with the last activity. What's your data going to look like once you've got this? Well, remember when you email the data to yourself, last time you saw time, you saw position, you saw velocity, and you saw acceleration. The only columns we cared about the last time were time and position. We ignored velocity and acceleration. In fact, most people, when they did their lab write-up, deleted those two columns, the velocity and acceleration columns. Now, you didn't lose marks if you didn't delete those columns, because that was data that you saw on your iPhone. But you didn't need those last two columns. Today, you need this column, you need this column, and you need this column. Now, you don't need to delete the position column. It's okay to include that. But we don't need that for our analysis today. Sorry, I lied. You do. You don't need it to do a calculation, but you do need it for a graph that you're going to see, that you're going to have to plot. So you do need all four columns, sorry. So that's your data table. Now, what does your analysis look like? This time, there's some questions, just a few questions. It's not too intense. There's some things that you've got to answer. The first thing you're going to do is plot a position time graph. Okay, and that position time graph is going to be plotted by the second column and the first column. You should expect to see a position time graph that has a shape something like this. I want you to reference that graph and answer question number 1. So you're describing the motion of the cart using the position time graph referencing the shape of the graph. In other words, you're not telling me a number. You're just telling me it's going at a constant velocity. It's accelerating. This is how I know it's going at a constant velocity. This is how I know it's accelerating, or whatever the case may be. Zane? Well, you can either write these questions down or have a look at the podcast again when you're ready to write it up, or even just snap a photo of the questions if you want with your phone. That's okay too. You also need a velocity time graph. And the velocity time graph is going to be plotted with the third column in the first column. Your velocity time graph should look something like that. Your velocity time graph is going to be used in question number 2 to calculate the acceleration. Now, if you remember from last time, your graph or your spreadsheet will give you the slope. You don't need to do it by hand. Your spreadsheet will calculate the slope for you. And if you remember when we talked about velocity time graphs, the slope of the velocity time graph is the acceleration. So what are you going to do for question number 2? Calculate the slope. Now, it says show your work. What do I mean by that? Well, if you do it by hand, show your work. Show me what you did if you did it by hand. Now, you can write it out by hand and take a photo of it and insert it into your document, but I don't need you to show any work if you're using the spreadsheet to get the slope for you. Okay? The only reason I want you to show work if you're doing it by hand is so that I know you didn't copy it off of somebody. Okay, if you're doing it on the spreadsheet and therefore the graph, then I know that you've done it properly because the spreadsheet's going to show me. So we'll say show your work. We'll put a little asterisk beside that though, just telling us, look, if you're doing it on the computer, there's not really any work to show for that. Now, there is a third graph that you're going to plot that you've never plotted before. It doesn't matter. The third graph is the acceleration versus time graph. Now, what do you think that one should look like? You guys could have easily predicted the shape of the first 2 graphs. What about the third one? An acceleration time graph that you've never seen before. What shape do you think that's going to look like, Carrie? Straight flat, you mean, like this? Yeah. Yeah. It should be relatively straight and relatively flat. Now, question number 3 asks you to reference the acceleration time graph. Determine the acceleration of that. Now, you do need a line of best fit through there, but you don't need to calculate a slope. The slope should be 0. The slope does not represent the acceleration. How are you going to get the value of the acceleration from that graph? Bruce? Sorry? Not even up and over. Well, I guess technically it is, I guess, but if it's a flat line, it's the same everywhere, right? So it's just going to be whatever the y-intercept is there, right? So I guess technically that's up and over, yeah. So get the acceleration from the acceleration time graph. You've already got the acceleration from your velocity time graph. You need to compare the 2. Make sense? Now, your problem in this lab, I should have mentioned this before as opposed to now, but we're going to the conclusion here, so we need to address what the problem was. The problem with this lab was to describe the motion of an accelerating cart and find its acceleration. To describe the motion of an accelerating cart and to find its acceleration. Your conclusion should go back to that. So your conclusion should essentially summarize your answers to these 3 questions. And how do you know? So what did you learn? The cart is experiencing constant acceleration. The cart is experiencing constant velocity. The cart is experiencing increasing acceleration. Whatever the case may be. The value of the acceleration is blank. We know this because blah, 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 blah. And go back to the graphs because that's going to tell you all the stuff you need to know for that. And then finally, again, sources of error. What are we going to need to hand in for this? We're going to need a problem. We are going to need materials. We don't need variables this time because we're finding a couple of different things and plotting 3 different graphs. I'm going to allow you to not do variables this time. Problem, materials, the procedure, your data, which is that table that I gave you on the previous page, the analysis, which is the 3 graphs and the answers to those 3 questions. The conclusion, and your sources of error. Sources of error including ways to improve it for next time. Any questions about that? Okay, once again, just a general reminder, when you're collecting data and syncing your iPhone with the AirLink, make sure you follow the instructions that are given on the sheet, the little handout sheet that comes with the AirLink, to the letter. Okay, it worked pretty well for us last time. Okay, we didn't have any major issues in terms of the AirLink not working. Okay, but if you don't follow those instructions to the letter, we will have those issues. Follow them to the letter. Okay, don't assume that just because you did it well last time, that you're going to do it well this time by memory. Have the instruction sheet in front of you. Make sure you're reading those instructions as you're syncing your phone to this AirLink. Now, you will probably notice, okay, a whole bunch of different AirLinks on your phone when you turn on the Bluetooth. Right? I didn't even mention this the last time. Didn't seem to be a problem last time, but I'll mention it again this time anyways. You probably notice a whole bunch of AirLinks on your phone when you turn on your Bluetooth. Okay, make sure you pick yours. Okay, they're all numbered. Make sure you pick the one that's yours. Don't pick your neighbor's, because you don't want your neighbor's data. It's going to mess them up too, because they're not going to be able to connect if you do that. Okay, make sure you pick yours. Got it? Questions? Okay, let's get at it.